So again, 5/8 about solving radical equations. So let's look at our first example. The only radical in this particular equation is onto 3. Luckily for us, it's not on the x. Now let's just think if that was a normal 3, and we wanted to solve that equation. Wouldn't we do the good old trick? Let's get the x's to one side and the numbers to the other side. It's the same thing. Let's get anything that contains an x, well, let's take it to the left, and anything that does not, let's push it over to the right. And so I'm going to subtract an x squared of 3 from both sides. And then I need to get rid of this 4, so I'm going to add a 4 to both sides. Okay. So I'm just going to move things around. And so I'm going to get x minus, and I guess let's write that as square root of 3x equals 4. Now all I did was just do a little flip-flop. I put the square root of 3x to the left and the negative 4 to the right. Now, in past equations, these two were usually like terms. We mushed them together, and we were much better off than we were before. But these are not like terms. So remember, earlier in the chapter, we discussed factoring. This is a time where factoring is going to be something we have to do. There's no other way to get the x by itself. So at this point, let's factor out an x. Now, when we factor out an x, remember what's technically happening. We're dividing out an x from both of those things. If we divide the x out of x, x divided by x is 1. Don't forget to put that 1 there. That's very easy to do. And then we have a minus square root of 3. That's a little easier to see. Now, what's happening here? Well, x is multiplying by this quantity. So in order to get this thing off of there, we're going to divide both sides by that thing. So that's the next step. Let's divide both sides by 1 minus square root of 3. And then technically, these are going to cancel, so we have technically solved for x. Now that is our answer, but we have learned enough about radicals so far in the last 2 lessons. If you saw an answer that looked like that, you shouldn't leave it like that because it's not rationalized. So we're going to multiply by, remember that word? What's the thing we're going to multiply by? What's it called? Begins with a C. The conjugate. So we're going to have to multiply top and bottom by the conjugate. And so multiply top and bottom by 1 plus square root of 3. So that it is in the correct format. Well, the number on top, that 4, just distributes. So we get 4 plus, sorry, I made a shape mistake. 4 plus 4 square root of 3. And on the bottom, we can use the difference of squares, which is going to be 1 minus 3. Now, in this particular case, you should never leave a negative in the bottom, so we definitely need to divide both by negative 1. But since both of these pieces are exactly divisible by negative 2, this is a perfect example where you should divide it, and it has to divide into both pieces. And so our final answer is negative 2 minus 2 square root of 3. Your final answer is negative 2 minus 2 square root of 3. Now, how would you check these? Well, if you put into a calculator negative 2 minus 2 square root of 3 and you take away 4, that should be the same exact value as if you put this into a calculator and multiply it by square root of 3. So you can check it, but I would most likely want to check it in a calculator. And, you know, the calculators might read a really funky long decimal, but you should get the same thing on both sides no matter what. Okay. So there's example 1. Now that's where a square root is stuck on a number, not the x, but a number. In example 1b, this time our square root is stuck on the x's. So in a way, this equation is a little easier than the last one. Because the thing that's going to get rid of that square root is to inflict or put a square on both sides. Because we know that the square root and the square are opposites. They're going to cancel each other out, which is great. It's going to make our life easier. And so we're going to get 3x minus 2 equals 4 squared. Well, what is 4 squared? 4 times 4 is 16. And now it becomes a much more doable sort of equation, an equation that we're used to, the equations we've seen in the past. We're going to add 2 to both sides. We're going to divide by 3. We're going to solve for x, 6. Now, how could you check this? Well, if we put 6 into the original equation, did the math, you better get an answer of 4. And you would. You would get 16 under the square root. The square root of 16 is 4. So those ones aren't bad. You know they're going to get a little worse. In example 2. Here, they're going to get a little worse. We still want to use the technique. Let's get the a's on one side, and the things without an a, the 2 and the 7 on the other side. Just like a normal equation. That's always the first step if you can. So let's subtract 2 from both sides. And let's subtract 2a squared root of 3 from both sides. Now here's the part that's kind of interesting. But I'm a math person, so these are like terms, so you can't subtract them. If I have one of them and I subtract 2 of them, I have -1 of those things. Now you can write the -1 or not, it doesn't matter to me. And then our equals, because these are going to cancel. These are going to cancel. So it's going to equal to whatever 7 minus 2 is, which is 5. And now it's just, because they were like terms, it's actually easier than the very, very first one we did. This time now, we have to divide both sides by whatever's stuck on the a. Well, we have to get rid of the negative and the square root of 3. And so our a is equal to -5 over square root of 3. It's customary to put that negative up at the top. If you left it down at the bottom, it is correct, but it's customary to put that negative to the top. It's also customary to not leave your answer with a square root in the denominator. So we got to rationalize. Multiply top and bottom by the square root. And our final answer is -5 square root of 3 over 3, because you would have gotten a square root of 9, which is 3. Hence, look what happened. The square root popped to the top and left a normal 3 behind. That's very common. Okay, so there's example 2. Let's look at example 3. Do I want to do example 3 first? Yeah. Let's go to, we're going to actually do 4, 5, and 6. I want to leave 3 till the last. It's the hardest one, and it's the most complicated one. So let's do 3 at the very end. So skip 3. Let's go to 4. Well, what's interesting about the rules we learned in 5-7 is that the 3 acts like a power, and the 2 of this fraction acts like a square root. But what's really cool is what we can use in the equation to get rid of it is we can take each side to the reverse or reciprocal power. Because what's going to happen? Well, the 2's are going to cancel because we square rooted a square. That's perfect. The 3's are going to cancel because we cubed a cube root. So by multiplying each side's whole entire thing's power by that reciprocal, things cancel out nicely. And so we get x minus 3 is 64 to the 2/3. Now let's take 64 to the 2/3 and do what we did when we were learning lesson 5-7. That is really the cubed root of 64, and that answer squared. Well, the cubed root of 64, what number times itself 3 times gives us 64? It's 4. So this is really 4 squared, because this thing is 4, so it just becomes 4 squared. Well, 4 squared is 16. Add 3 to both sides, you get your answer. Okay? So that's example 4. Now I'm pretty sure example 5 and example 6 are very, very similar. Any questions on example 4 so far? Kind of makes sense maybe a little bit, I hope. Okay. Now example 5, it's really going to be the same exact process. Here's the difference. In a square root equation or an equation with fractional exponents, you never want something extra on the side with the square root or fourth root or power. So we've got to move this 1 before we do anything else. So to fix the problem, just add 1 to both sides. And now it's very much like the left example. What's going to get rid of a 1/4 power? Well, multiply both sides power to 4. Because the 1/4 and the 4 will cancel out. It's just like if we had a 4th root, we would take n to the 4th power on each side. And so what do we get? Well, we get 2t plus 1 equals 3 to the 4th. What's 3 to the 4th? 81. 3 times 3 is 9 times 3 is 27 times 3 is 81. Now just solve it. So subtract 1 from both sides. Divide by 2. We got it. So that is that example. So let's go on to the next one. Any questions there? Okay, let's go on to the next one, then we'll jump back up to that gross one. Yeah, let's do this one. So same idea. What's wrong with this before we do anything else? Yep, got to get rid of that 2. So add 2 to both sides. So we get 3y minus 1 to the 1/3 equals 2. Now, what's going to get rid of that 1/3? That's like a cube root. Like taking it to the 3rd power, right? Cube it. So 2 cubed, that is a 2. It's a very ugly 2, but 2 cubed is 2 times 2 times 2. So that's 8. So we get 3y minus 1 equals 8. And now just solve it. Add 1 to both sides. Divide by 3. Okay? A lot of them are like that. Always make sure your square root or your fractional exponent is isolated. Get it by itself before you try to solve the equation. Now, let's go back to example 3. Now this is how I knew this one was kind of See how there's a square root in 3 different places? Because of that, if I try to square everything, it doesn't work. And here's why. Well, it's going to work eventually, but it's not going to work exactly the way we want it. If you square both sides, you have to put parentheses around that entire right side. The left side squared really nice, but the right side is technically that whole side written twice. So what do you got to do? Well, it becomes a foiling. You got to foil it, unfortunately. So let's take and FOIL, distribute that side. So we get x minus 3. Square root of 2 times square root of 2 is 2. Square root of 2 times square root of x is negative square root of 2x. Now we're going to distribute that. That's going to be negative square root of 2x minus x. So what do we got? Well, unfortunately, look, we still have some things containing square roots. So we're going to get everything that doesn't to one side, everything that does leave to the other side. So now at this point, let's subtract 2 from both sides. And let's add an x to both sides, since those things do not contain a square root. So what do we get? We get 2x minus 5 equals. Now, I technically have 2 of these things. So I can write them as negative 2 square root of 2x. This is the kind of equation where we don't have to square both sides just once. You got to unfortunately do it one more time. And these are the hardest types. So we're going to now square again both sides. Get rid of that square root. So what do we get? We get 4. Okay, so let me tell you, I was just going to do it, but remember, that's really 2x minus 5 times 2x minus 5. Okay, so if we distribute, we're going to get 4x squared minus 10x minus 10x plus 25. So see how I just distributed 2x minus 5, then negative 5. Got that big long list. And on the other side, what do we get? What do we get? What do we get? Well, we get 4 times 2x. So we get 4x squared minus 20x plus 25 equals 8x. So for this, you would set it equal to 0. You would get 4x squared minus 28x plus 25 equals 0. This is a perfect example for slide and divide. 4 times 25 is 100. What are the factors of 100 that would add up to 28? Oh, 25 and 4 is not it. Close, but not it. I'm thinking. So 50 and 2, 101, 25 and 4. That's the closest so far, but it's not it. No, 5 and 20. That's 28, or not 28. Do you guys remember that we haven't talked about yet? Back in Algebra 1, you remember the quadratic formula?
Quadratic.
It's negative b plus or minus the square root of b squared minus 4ac all over 2a. There's a song. I'm not going to sing it for you. But if you cannot see a way of factoring this, I will always give you one that's factorable. So I apologize that it's not factorable. At this point, if it's not factorable, you should use the quadratic formula. But we're just going to leave it right there for now, okay? So for in future reference, if you have it on the homework, it will be factorable because we haven't discussed the quadratic formula yet. So I'm not sure exactly unless I made a funky mistake somewhere. But there you go. Okay. Now let's talk about homework. So your 5-7 homework is due tonight, I think. Yeah. Now let's talk about the 5-8 homework. The 5-8 homework, I'm not going to have you do all of them, so don't freak out. You're only going to do the evens, and we're going to do some of them tomorrow together. So make sure that you put this into Notability so that you have it. Scratch out the odds or put yourself a note that you are only going to do the evens, okay? This is your assignment, just those evens. There are two inequalities. Skip 26 and 28. And in their place, could you please add in 19 and 21? Okay, so you're doing all evens and, except 26 and 28, add in 19 and 21. That is your assignment.